Hello students, in this video we will explain lesson 4, which is powers of monomials. We will learn how to calculate the power of a power. Let's take an example. The main rule is if we have 5, let's say squared, and all of them are to the third power. How can we calculate it? The rule says that if we have a power of power like this, a power of a power here is 3, over the power 2, okay, we just multiply them. So the base here, which is 5, is going to be to the power of 2 times 3. So the exponents, we will multiply them. So we will have 5 to the power of 2 times 3, as simple as it is. Then we will have 5 to the power of how much? To the 6th power. Okay? This is different from calculating the power when we multiply two similar factors. Let's say we have 5 squared times 5 to the third. This is from lesson 2, from lesson 3 actually, and we just here we have the same factors, the same base, okay, and the multiplication between them. So in this case we add powers, so we write 5 to the power of 2 plus 3, which is 5 to the 5th power. Okay, see the difference? Here we have power of a power. Here we have a multiplication between two numbers, two exponents with the same base. So we write the same base and just add the exponents because we have multiplication. If we have a division, we just subtract them. Okay, let's take examples from the book. So let's solve the first example. Page 32. Page 32. Examples from page 32. The first one is 8 to the 4th, all of them are to the third power. So how can we calculate these? We have a power of a power, so we simply multiply them. So the answer will be 8 to the power of how much? 3 times 4. 4 times 3, which will give us 8 to the power of a 12. Example number 2 from the same page. We have k, some variable, to the power of 7 to the 7th power, and all of them to the 5th power. Okay? All of them to the 5th power. So we have here a power of another power, so we multiply them. In this case, we will have k to the power of 7 times 5, which will give us k to the power of 35. Okay, as simple as it is. This is the first part of the lesson. The second part is how to calculate the power of powers if we have an expression, and this expression has more than one variable, more than one numbers, have numbers and variables. Let's look at example 3, page 33. So example 3, page 33. Look at example 3. It asks us to calculate 4 times p to the third, and all this expression is to the 4th power. How can we solve this? What do we do in this case? Exactly. How many factors do we have between the parentheses? We have 4 here, which is a number, and we have a variable here called p. Okay, so we simply distribute this outer exponent here. We just distribute it into the inner exponents, inner factors. Don't have to be some exponents. So we distribute this exponents, the outer one, to the inner factors. So we can rewrite this expression as numbers alone, the number 4 to the power of how much? Nothing here, so it's gonna be to the power of 4. Okay, and what is the mathematical process between 4 and p? It's a multiplication. It must be a multiplication or a division between them to allow us to distribute the exponents. If there is a subtraction or an addition between them, we cannot just distribute the exponents. So let's continue. So we distributed these exponents, this outer exponents, on the first factor, and now we do the same for the second factor. But the second factor is to the power of 3. So we write it like this, times, because there is a multiplication between them, p to the third, and this p to the third is to the fourth power. Okay, that's how we can rewrite this expression. Now, how can we calculate these? 4 to the fourth, we can calculate it in numbers, okay, but we can just write it as it is, okay, and deal with the p. How can we calculate this? We can simply write the same rule for today, which is we have a power of a power, so we multiply them. So we can write 4 to the fourth times p to the power of 3 times 4, because when we have a power of a power, we multiply them. Okay, so this is gonna be 4 to the fourth, give you, if you calculate it, 256. Okay, times, now p to the power of how much? 3 times 4, exactly, to the 12th power, to the power of 12. And this will be the answer. Okay, as simple as it is. So let's continue with example 4 at the same page. So at the same page, page 33, we have example 4. Number 4, which is asking us to calculate -2 times m to the 7th times n to the 6th, and all of these quantities are to the power of 5. How can we calculate it? So the rule will not change. We have the same rule. We have an outer power there, and these are factors between the parentheses, and there is a multiplication between them, so it is safe to distribute this power here on each factor between the parentheses. How many factors do we have? We have -2, a number, and we have a variable here called m, and here we have another variable called n. So we simply can distribute this 5 on each one of them, and we can rewrite this expression as, let's write it here, we can rewrite this expression as -2, the first factor, to the power of how much? Exactly, to the 5th power, times the second factor is m to the 7th, so we write the same m to the 7th, and all this factor is to the 5th power. Okay, and then the last one is n to the 6th, and we distribute the exponents on them, so they will be n to the 6th all to the power of 5. Okay, so we can simplify that by saying -2 to the 5th power. How much is that? We can simply multiply -2 5 times, which will give us 32. But will it be negative or positive? Okay, we look at the exponents here. Is it an odd number or an even number? If we have a minus sign between the parentheses, Okay, we look at the exponent. If it's even number, the answer will be positive. But here we have an odd number, so it's gonna be negative. Okay? Or you can simply calculate that by calculating negative 2 times negative 2 times negative 2 5 times negative 2 times negative 2. Negative 2 times negative 2 gives you positive 4, and positive 4 times negative 2 gives you minus 8. Minus 8 times negative 2 will give you positive 16, and then positive 16 times negative 32, negative 2 will give you negative 32. So you can calculate it numerically to know the sign, or you can just write the sign, depends on the exponents, whether the exponents is odd or even. Because here it is an odd number, so the negative sign will remain in the answer. Okay, times how much? Times m to the 7th all to the 5th power. How can we calculate this? Based on in today's rule, we just have a power of a power, so we multiply them with each other. So the answer will be m to the power of 7 times 5 times the same process here. We just multiply them together, so we have n to the power of 6 times 5. Okay, we can simplify more than that by writing the answer. That will be negative 32 times m to the power of how much? Of 35, 7 times 5, times n to the power of how much? 6 times 5 gives you 13. And that's it. So I will see you in another video. Solve questions from the guided practice, page 34. Thank you.